Okay, so this video is about carbocation rearrangement, and the first thing you want to ask yourself is what drives rearrangements. In order for you to predict what is the simplest mechanism that we can think of that has carbocation rearrangement, what drives rearrangements? And the answer is that the rearrangements are driven by a lowering of energy, right? Of the carbocation. Handwriting is really messy today, okay? This is the critical thing, a lowering of the energy of the carbocation, alright? So what we're not going to do is we're never going to see a rearrangement go from a secondary to a primary carbocation. That's never going to happen, right? Because that would be increase of energy. We're never going to see a tertiary to a primary. We're never going to see a tertiary to a secondary, right? We could see a primary to a secondary, a primary to a tertiary, or a secondary to a tertiary, right? Those we could see. However, we'll almost never see a primary carbocation. And so, boom. That's what we're looking at, right? Excuse the music. Alright. So that's what we're looking for. A secondary carbocation going to a tertiary. So you basically can turn your mind off to carbocation rearrangement unless you see a secondary carbocation. There could be some exceptions to that, but for now I think you really ought to focus on that. If you see a secondary carbocation, you ought to look and see if I can get a rearrangement to make a tertiary. Then yeah, that's what's gonna happen. So let me give the first example here. Let's suppose we take that and HX, alright? And I admit, I thought ahead about that, and you really should have thought about it. It's too late now, I didn't tell you to pause it, but alright. This is an example, maybe the simplest example of something that's going to give us a rearrangement. Alright, so let's look at this mechanism. First of all, boom, and boom. Easy. There's our new hydrogen. There's a secondary carbocation, right? And can you see that I've got a hydrogen here and a methyl group? If the hydrogen goes, let's consider both of these. If the hydrogen goes and if the methyl group goes. If the methyl group goes, let's say that that's 1 and this is 2, okay? If the hydrogen goes over, then it's going to give us, you should pause the video at this point and predict what happens if arrow number 1 goes. Okay? If the hydride goes, then we're going to get that. Right? Where that hydrogen ends up over here on this one. Okay. If the methyl group goes, pause the video here and say, this is arrow 1. Pause the video here and predict what goes here. Okay? If the methyl group goes, then we're going to get that. Alright, and that is the same thing as this. So a methyl rearrangement is useless to us. But we do have a secondary carbocation here, boom. And we can, with a hydride shift, get a tertiary, which deserves, I think, 2 exclamation points. Okay, so with a tertiary carbocation, then we still have this halide over here. Boom, 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 boom. Boom. And you should pause the video here and write out what that product is. Okay, and that's it. So this is an amazing reaction. Here's what the reaction looks like. This is the full mechanism over here, right? But what does the reaction look like? HX. Wow. Okay, and you can see why this is something you're going to want to think through before game day. Best wishes.